Let's know quadratic equation. Quadratic equations are second degree algebraic expressions and are of the form ax square bx plus c equal to 0. An example of quadratic equation is 5x square plus 3x plus 3 equal to 0. This represents quadratic, and also this equation is in one variable. From the name, we can say that the meaning of quad over here is square. That represents the variable, that is x square. Also, if you see, the highest degree of x is 2, so it is also called as equation of degree 2. This type of equation has maximum 2 solutions. We call it as real numbers or complex numbers. Or I can say the solution can be in real number or complex number. Over here, the solution is called as roots, which is represented by alpha and beta. Let's see standard form of quadratic equation. The standard form of quadratic equation is ax square plus bx plus c equal to 0. Over here, a and b are said to be the coefficient of x square and coefficient of x, and c is called as constant. A, b and c are known values. In the standard form of quadratic equation, a is not equal to 0, where in case of x is said to be a variable, an unknown value. Let's see some examples. 2x square plus 5x plus 3 equal to 0. We first write the standard form and then compare it. So over here, if you see, the coefficient of x square is 2, so the value of a becomes 2. The coefficient of x is 5, so the value of b becomes 5, and so on. So c becomes 3. Let's take another example. X square minus 3x is equal to 0. So the coefficient of a, that is coefficient of x square, becomes 1, that is a is equal to 1 and b is equal to minus 3. Over here, we don't have the value of c, so we consider c as equal to 0. Let's take another example. 5x minus 3 equal to 0. Over here, if you see, there is no coefficient of x square, therefore it does not form a quadratic equation like we have seen before. For a standard form, a cannot be equal to 0. Over here, the value of a is considered to be 0. How to solve a quadratic equation? So when we solve a quadratic equation, we have either real number or zeros. Those are like roots. Finding the factor of quadratic equation is considered to be factorization. Over here, we split the middle term. The next method is the completing square method. Over here, we find the value of b, divide by 2, and we square them, and we add and subtract with the quadratic equation. We also have quadratic formula, that is x is equal to minus b plus minus under root b square minus 4ac upon 2a. Over here, the plus and minus represents two values, that is roots. We can also write x is equal to minus b plus under root b square minus 4ac, and also with x is equal to minus b minus under root b square minus 4ac upon 2a. As we know, there are two solutions of x. Imagine if the curve just touches the x-axis, or imagine the curve is so high it does not even cross the x-axis. Therefore, we have b square minus 4ac, which is derived from the formula itself. When we get a positive value, we have real solution, and when we get 0, we have one real solution. And when we get negative value, is said to be complex solution, or we can say no real solutions. Let's take an example and solve it by using the quadratic formula. (5x square plus 6x plus 1 equal to 0). We first compare it with the standard form, that is ax square plus bx plus c equal to 0. We get a is equal to 5, b is equal to 6, and c is equal to 1. Now we substitute this value in the formula, that is minus b plus minus b square minus 4ac upon 2a. We write it as minus 6 plus minus 6 the whole square minus 4 into 5 into 1 upon 2 into 5. We get x is equal to minus 6 plus minus 36 minus 20 upon 10. Minus 6 plus minus 16 upon 10. We get minus 6 and we take the square root of 16, that is 4. We first write it with plus and the other solution with the minus, that is minus 6 minus 4 upon 10. We get minus 2 upon 10, or x is equal to minus 10 upon 10. So we get two roots, that is x is equal to minus 0.2 and x is equal to minus 1. Let's see complex solution. We take an example 5x square plus 2x plus 1 equal to 0. We first compare it with the standard form, that is a square plus bx plus c. We get the value of a, b, and c. Now when do we get the complex solution? When we get a negative integer inside a square root. So we first find the discriminant value to check whether value is positive or negative. We substitute the value of a, b, and c. We get 4 minus 20, which is equal to minus 16. Now we substitute in the general formula of quadratic equation, which is minus b plus minus under root b square minus 4ac upon 2a. When we substitute the value, we get minus 2 plus minus minus 16 under root minus 16 upon 2 into 5. Now the under root minus 16 can be written as under root minus 1 and under root 16. Under root minus 1 can be represented by iota, which represents imaginary term. As we know, I square is equal to minus 1. So we can write it as minus 2 plus minus 4i upon 10. 4 is nothing but the square root of 16. Now we can write it as minus 0.2 plus minus 0.4i.